visible?
Yes, it is visible.
Okay. So we have talked yesterday about the natural language processing, then machine learning and the deep learning at a very high level. What are the subtypes? And then we saw how the machine learning can be used to solve the natural language processing problem. And then we have looked at the example of sentiment analysis, which was a very simple example using some scikit-learn library where we used a model called SVM, and we saw the accuracy was almost about 92%. So this was exactly in brief what we did yesterday. So now whatever model we are building, whether it's a sentiment analysis or maybe a model which can be used by millions of people, we need to take it to the production. We need to release to the real world. So for doing that, if we do that, then there are a lot of people who will be using our model. So it's important we should understand that from whatever model we are developing, how we can go to the production. So that's the overall idea of what I will be talking about today. So yeah, it's a very, I think a lot of people usually just ignore this part, why, how to take it to the production. Then later they face the difficulty with a large number of users using their model via some website or some other way. So later they realize there is some problem, then they try to rectify. But if we have some at least basic idea, what are the possibilities, how we can take some model to the production, then it's a good thing when we are developing some model and taking it to a large audience. So yeah, so when I was exactly delving into the details of how exactly I can go to the production, there's no such little, there is no book or something which talks about this thing. But recently this year, there is a course at, if you can see my screen, at University of California, Berkeley. So there is a course which is full stack deep learning. So this is the first course which I find it very attractive in a sense that they focus on the production level of machine learning. Most of the research paper which you'll see, most of the stuff which you'll see online, like let's say I Google something called, I want to take the ML system to the production. We'll find a lot of small blogs which talks at a very high level, what does how we can take it to the production and all those things. Not much details is there which you can find. But this is some course, full stack deep learning. It's a 2020 course. I think it's ongoing course. So here, this person talks about a lot of detail. What are the possibilities? What are from development to deployment we can exactly take. So the idea for today talk, and even the slides are borrowed from this particular course called University of Berkeley. There is a course called full stack deep learning. So first we'll talk about some production things, and then we'll talk about something called how we can, when we develop some model, how we can troubleshoot the thing. So these are the two basic ideas, and yeah, so we'll just get started with. Okay, so as we know, even in the software development cycle, we have something called, yeah. In software development, usually we do the development, then we do the deployment. But in the machine learning, there is one more stage before the development that's called data collection, data pre-processing, and all those things. So there are a lot of tools you can see here. Some database is there, some Hadoop system is there, some network storage. There are a lot of tools which can exist in this part. I'm not talking about this data part right now. The main focus of the talk is deployment and some troubleshooting. Now, the development in terms of machine learning or the deep learning is basically about how we can develop the model. Like I have talked about few libraries also, not exactly LNAI. I have given some demo yesterday. So that is based upon the PyTorch. Then there is a TensorFlow. Then there is a Keras. So these are some framework or libraries we can use to develop machine learning or deep learning model in a very good way. These are some popular software engineering tool like VS Code, Jupyter Notebook. So all those things are there existing. So also for resource management, Docker is one of a good thing. So this is not a part of our talk. Just I'm giving a brief idea that these are the tools or the techniques which we can use if we really want to develop in a good way and take it to the production. Now comes the task of, after we have done the developing the model, now we need to deploy it to the real world so that a million or a billion of people whoever want in the world across the globe, they can use it. So there are a lot of steps exactly here required if we literally want our system to perform very well. It can serve everyone. So yeah. So the overall idea is about, we'll talk about the project structuring, how we can exactly say whether our model is good or bad for production, then some infrastructure and tooling. And then this is the most important aspect, because whatever we are developing, let's say in WhatsApp also, we are typing something, we get suggestion. For Gmail, we are getting some suggestion. So we are deploying it to mobile in most of the cases. And in this today's scenario, everyone uses mobile. So one of the most useful cases, like how we can deploy this complex model to the mobile. So here we'll see some codes also, and some, how we can exactly go there. So before that, we'll cover all those tooling or whatever is required to take it to the production level. So this is the overview of this deployment part. Yeah, so at a very high level, you can consider there is a training system. So what exactly it does is like process whatever the data collection, you can say, processing of that data, how we can manage the ML experiment and manage result. Now we may think that why don't write everything in a single file? Because see, if we have to take to the production later on, a lot of new changes we can add. So all those things, so maintainability is the main requirement. So that's why we need a training system which manage our prediction system. So this is this prediction system is the ML system or the deep learning system or the NLP system. So it is managed by some training system. So this is a good practice to maintain this as a separate module so that we can take advantage for some other project. Also, reusability and maintainability are the two things which we consider over here. Now the prediction system is basically, we have talked about yesterday that how we can develop, at least at a very high level, I have talked a sentiment analysis system. You can apply to any domain, whatever you want, with the libraries like TensorFlow and the PyTorch. So this is the exact ML system existing over here. Now, whatever code I have run for the single user. Now, if we have to take it to the production, so we need some extra system which will exactly take the output of the system and then serve to the user, whoever is using the system. So there are overall 3 components in which we should try to divide our system if we are taking to the production. First is the training. Second is the prediction, which is the actual model system. And this is the you can say web component, or the Android or the iOS component is the serving system. So this training system uses the training data or the validation data to just look how our system is performing. And this serving system works on the production data, which is unseen, totally unseen, any data, whatever we feed. So this is overall thing. Now, if our project is getting bigger, suppose millions of people are using it as a developer, if I commit some mistakes, so it's better if we have some automated testing in place, so that by default, when we commit something to our system, it should tell me directly, immediately, before going to this serving system, that there is some problem. So for that, we have some test in place, like for training system, we say training system test. For prediction system, we have some functionality test, validation. We'll talk about this very, very briefly. And then also for the serving system, we should always monitor how exactly the system is behaving, what's the downtime, what if the data is coming, is it some extreme data or something, distribution shift is there. So all things are there. So here, the main idea of this slide is about system and its testing, how we can distribute the system and what are the possible testing we can do. So this is also much with respect to software engineering in machine learning, because that's also one of the good things which people don't talk about. And this course, whatever I talked about, UC Berkeley is a very good course which talks about how we can integrate all those things. Okay, so once we have a brief idea at how we can structure our system, now if we have to take some system to the production, so there are some score exactly. So there is a paper by Google called A Rubric for ML Production and Technical Debt Reduction. So they talk about if some system, some ML system satisfies some score, then we can take it to the production with without much difficulty, in a sense that the end user will face very less difficulty because the system is well maintained, well tested, and all those things. So this is a paper. You can go through this if you are more interested about how and what exactly they are saying, but we'll cover the brief idea of this year. So these are some recent paper like 2017 paper, and also some more paper developed on top of this paper. So it's all about the chain of things. Some people propose something, then some more people is proposing something else, that how exactly we can take some, just think about the Google search engine. The entire planet is using that, right? So how exactly they are maintaining those systems? So based upon those learning, these guys have written some papers and all those things. In the initial go, they also were very bad in a sense that how they were taking to the production, because they also talk about some of the score that they have surveyed within the organization. It was not very good, but with time they have improved a lot in this production system of the ML thing. Okay, so yeah, so we have talked about the score. Now let's see how the traditional software and the machine learning software varies in terms of deployment at a very high level, not too much detail. So in traditional software, we have something called code, and then we have some machine running system libraries installed, and then we take that code over there, run and serve, and whatever is required. So we have some unit testing also in the code. Usually we don't write it, but for a production code, any production code you reach, most of them write the unit testing. They look for the code coverage and all those things. Then integration testing is also one of the important tasks, because suppose I'm making some bug fixes. If it has to go to the production, then when I commit to the Git, then by default it should say that this is good or bad. So that is basically done by integration testing. And also system monitoring, how does the system is behaving, the runtime and all those things is monitored by this thing. So this is the overall overview of how we consider a traditional software in production. Okay, sorry. Yeah. In machine learning phase, we have the code, we have the running system, but before that we have something called a model training phase. So, and also we can write the unit test. There are very few people who are writing the unit test for machine learning, but it's a good practice, because if you write a very long function, it's not maintainable at all. So unit test writing over here is also integration testing is required, system monitoring is required. So these three things are required here also. We just try to distinguish how exactly these so on the top we are trying to rename, like we don't say unit testing over here, we said ML infrastructure test and all those things. So basically, instead of these three terms, we'll use some infrastructure test, model test, data test, Q test. We'll see all in a very brief for what these things are. Then monitoring test, all those tests are there. So on the top, these 6 tests are equivalent to these 3 tests in the traditional system. So also you can consider the training system, whatever test we are doing, it is equivalent to ML infrastructure test. This modeling, this is the exact modeling part. Here we'll do model test. This is a serving system, production system. Here we'll do some data related or the monitoring test and all those things. And here for data only, we'll do some data test. Why it is required? Because we want the data to be in good shape so that our model learns something good. Because data cleaning or the data pre-processing, we think is a very boredom task, but most of the companies spend almost 70% task in this data part and 25% in this modeling part. So yeah, data cleaning or the data test is also one of the important. Okay, so just a very few what exactly can be done is this test is like, if we talk about data test, feature expectations are captured. So whatever feature we want to capture, it is there in the schema. All features are beneficial, means we'll try to reduce some feature which may not be beneficial to us. Obviously, to extract the feature, not too much cost should be there. So all those things, there are much more over here. So these are some few of them. Data test means data is given, how we can say the data is good or bad or something. What are the things we can do? So that is all about a data test. Modeling test may see, a model has a lot of hyperparameter. When I say hyperparameter, so yesterday we have seen like support vector machine. So there we have a lot of hyperparameter in terms of maths, like what is the regularization parameter and learning rate, and all those things are the some hyperparameter. So those has to be well maintained, because suppose you are doing some experiment, publishing a paper. If you are not talking about what are the specification of the models, what are the hyperparameters of the model, so it's a troublesome if some other person want to read your paper, try to reproduce the result. So that's also one of the important aspect. Then offline and online metric correlation, meaning when we train the model and when we test the model or serve the model, the metrics should correlate how in terms of our model is performing. So even hyperparameters, some more hyperparameters are there, like in deep learning world, how many layers we should keep. So all those things are also there. So for how much time the model is stale, how it impacts. So all those things are over here. Model testing. With respect to model, we can think a lot of things, and we should take care whether these things are good or not. Now the infrastructure test is all about the training. Whatever the training we are doing, some other person should be able to reproduce the same result. Because there are a lot of papers in this reproducibility domain where the people have published the result, but they haven't talked about how to reproduce. So that's one aspect we should also consider. Then unit testing of the model specs is also required. Then a lot of things are here, meaning the infrastructure, the GPU and debugging and everything we test over here. Now the monitoring means how the model is when deployed, how it is behaving and all those things. If it is not behaving good, then log it out, then find what's the reason. So all those things comes over here. So basically 4 type of tests we do: data test, model test, ML infrastructure test, and the monitoring test. So if we have to take to the production, these are some important aspects which we should care about. Okay, so just to give you an idea, like see, it's better to quantify in terms of some number, that how our system is, how our ML system is, so that if we so that if we take it to the production, what are the chances of it succeeding, or maybe it will give some bug here and there. So zero simply means that it's a research project rather than a production system. So also whenever we do here, most of the time as a research project, we write the code in a simple file and all those things, but production system are not like that. So if it is a 0 score, means you are saying data test is not there, 0 score, then think of it like it's a research project, not a production level project. 0 to 1 meaning, so these are some numbers which they are talking about. If it is greater than 5, that means exceptional level of automatic testing and monitoring is there. It's a very in good stage to take it to the production. And 0 to 1, some testing is there, some is missing, and all those things are there. So these are some numbers which the initial Google paper talked about. So it's a very good way to judge whether our system is capable of going to production without any difficulty. So that's a very high level of deployment. Now we'll go into the internals, some internals of exactly how exactly we can take it to the production. So the first thing we'll talk about the CI, meaning continuous integration. These are already existing in software domain, but since we are dealing with ML domain, so we will just take a brief look at all those things and see how we can utilize. Okay, so I have already talked about unit testing, means a function or a class should be tested. Integration testing means if a developer is doing some changes, it should be integrated to the main branch directly. If it is some problem, then that integration test will find out. Continuous integration simply means whenever some person is pushing the code to the repository, let's say Git or GitHub or the GitLab, anything, then by default it will deploy, update the model. Updated model is deployments. It will directly integrate if everything is good. If all the test cases are passed, it will directly integrate. Now we have some software for continuous integration like Circle CI, Travis, Jenkins. So these are some just names. And I think currently, if you ask me, this GitLab CI is the most useful, most beneficial tool if we want to do the continuous integration. But before that, Circle CI and the Travis were good. Now also we should use some containers or the Docker. The reason I'll tell about this in the coming slides. So these are some basic terminology, I would say, which I have introduced here. Now in the coming slide, whatever I'm talking about, these cover these specs of things. Okay. So the Circle CI or the Travis is a CI tool. What does mean by CI? We do some changes, we push to the Git, it will by default, if all test cases are passed, it will try to merge. So that's what does this CI tool is all about. So we know in the machine learning world, we have GPUs also for training and for inferencing both, but this Circle CI and Travis don't support this GPU tooling in a good way. I think rather they don't support GPUs. So rather this is not so much useful for ML domain, but yeah, if we want to use for some other, like, because we have a lot of model where we use only the CPU, not the GPU. So there also we can use this thing. So just an idea. So Jenkins is a good tool if we literally want the ML system to have the GPU support. So yeah, it also has some GUI. So here Jenkins and the build kit are two good tools to use. So they also talk about, see, everything is good, they'll say good and all those things, deploy done. So these are some at a high level that CI tools are there. So these tools are also helpful for software development lifecycle without ML, but in ML also this is useful. Now, yeah, a very brief idea of Docker, and we'll see how Docker can be used to deploy for deployment, because Docker is a very important tool in today's world, and a lot of people use this for deployment. It removes a lot of headache. So we'll look at Docker versus VM, then Docker and its ecosystem, then Kubernetes also, what exactly. So just a very brief idea, because before using something, we should understand what the Docker is all about. So we may have used something called virtual machines, like Oracle VirtualBox is there, then VMware, VMbox or something is there from VMware. So what exactly is there? Let's say our operating system is Windows. On the top of Windows, we can run Ubuntu, we can run Fedora, we can run some other XYZ operating system. So that is one way how the VM works, how we can do some deployment, like just make a virtual machine Ubuntu and install everything over there, deploy the model there, give this OS virtual box to some other person, they'll use it. That's how one way we can do it. But that it has a lot of overhead, like we need extra OS on all those things. So yeah, a lot of things are there. So Docker what exactly does it? Says I don't need the OS. So if it doesn't need the extra OS, so it's a lightweight. So that's why we use the Docker. So you see, let's say host OS is Windows, and in top of that we don't have any OS. It just have something called Docker engine, and we install some libraries in some Docker containers, and then some machine learning app over here, and we can just deploy it. As simple as that. So basic difference between VM and the Docker is like there is OS in VM, separate OS, but here it doesn't require OS. It shares the host OS. It can be anything, Windows, Ubuntu. So that's how it should work. So it's a very lightweight, and that's why people are using a lot this Docker thing. And yeah, let's say for our example, like we have a container for something called Tomcat. We have a container for some web application PHP. We have some container for some other libraries also, some binaries need. And we can deploy, it can share the common OS. It can be Ubuntu or Windows, anything. So that's how this Docker thing works. It doesn't require extra OS. So it doesn't go to kernel space, no extra overhead, nothing. So that's what it is. So yeah, so how exactly we generate? So first we talked about Docker. Now, if we have to deploy as a Docker something like our ML model, so what exactly we can do? So there we need a Docker file, some Docker file. So this Docker file is basically, I won't go into the detail of this, but we write some Docker file, we install some libraries, we just run something as we do in the local system. So, but it runs on the host OS only. It doesn't require anything extra. And this is just a simple command to run this. So at a very high level, this is how it works. We don't go into the details of Docker file and all those things, but we should understand this diagram. So just like we have a GitHub, similarly, we have a Docker hub where we push the images. So in Docker, we have something called image, just like we have directly or file something. So from this particular file, we'll create some image. You can just consider image as a snapshot of all the libraries and everything. So we build image, we push image to this particular Docker hub. consider it's like a GitHub, and then we pull the image and run this, as simple as that. So see how the task is simplified. As a developer, I'll just push something over here. Any of the participant here, or anyone in the world can access that image with a one click. There is no need to set up anything and all those things. So yeah, just install Docker, run this command, you are good to go. So yeah, that's one of the advantage of Docker. Yeah, this is the same thing in terms of other diagram. So yeah, just to give a brief idea how Docker exactly is blooming is like in 2013 about Docker came into picture, and now see how exponentially it has started to use in the real world scenarios. So it is just growing again, growing at a very large scale. The people are using it for everything, ML or non-ML stuff. So yeah, so that's why here also in ML we try to use something called Docker for environment management and everything. Now, yeah, so I have talked about in Docker, we have two things, image, which we push, and when we run that image, that's called container. So you can take an analogy of a program and a process. So program is equivalent to image and a process is equivalent to container. So image in running is called container, as simple as that. Now, let's consider a scenario in which if we have let's say 100 users, it's okay to run one container. But let's say if we have a million user or a billion user using our ML model, so one computer is not enough. We have to deploy on a lot of computers, a lot of nodes, which we call those computers as nodes. So how we manage that? We can't manage it manually, right? It's a production system. We have to use something, some tool or some techniques how it can manage. So that is, there is an open source tool called Kubernetes. There are a lot of tools, but this is one of the best tool, Kubernetes, which we can use to manage the containers, that where to deploy, how to manage, if it gets down, how to get it up. So all those things are there. So this is also a tool by Google. It's an open source. It's very good. So it works on top of Docker. It may maintain the Docker, whatever we talked in the previous slide. Also, there are some other tools like Mesos, then Marathon and the Elastic. This is why AWS. So there are a lot of tools existing. So we should consider using this tool if we are going to production, because we don't know, maybe our whatever we are developing, it can be used by a lot of people if it is famous enough. So yeah, we should consider using Kubernetes and a Docker. Docker, why? Because it's a lightweight way to maintain all the dependencies, and Kubernetes for scaling up, because scaling is a uh, very hard requirement, I would rather say, because scaling manually is very difficult. So that's why scaling with some automatic thing is a good thing. Even if we are not monitoring it manually, there are some configuration which we can do. If the load is increasing, it can scale the Docker container from, let's say, 100 to 1000 if the number of loads are more. So those configuration can be done using the Kubernetes. So idea is not going to the detail of all those things. Idea is to just give, these are the things which we can use if we want to develop something. Someday we can go and explore and find out. Okay. So now we have done with the continuous integration and the deployment. Now we'll look at something more. Okay, before going into the main idea of serving, we'll first say when I use the term inference, it means making the prediction, meaning model is trained already. We'll put some input. Let's say in our case, we want to do machine translation. We'll put the sentence in Hindi. It will try to predict in English. So that's what the inference meaning. Now, the other concept is model serving. So model serving is a very simple thing when we want to use the GPU. Otherwise, we have web application. We can serve model directly using that. But if we want to use GPU, then the model serving is one thing we should consider, because normal web development doesn't consider the GPU uses and all those things. So it's a great way, and all the major framework like PyTorch, TensorFlow support this model serving. So yeah, just saying 3 because I am right now considering we have a lot of users using this. So I'll deploy this model to this first machine, second machine, and third machine. And then whenever a user, let's say some XYZ person wants to use our model, he'll go to the load balancer, and load balancer, depending, this load balancer knows on the load of his server, it will try to direct this load to the server which is less free at that point of time. So let's assume right now these 3 server maximum they can manage 1,000 user. But what if the number of users, something get very famous overnight sometime, or maybe over the time it get famous. So how to scale it out? So here we have to manually buy a cloud machine, cloud instance, and then install this model with all the libraries there. So that's one thing we can do over here. But this is not a good idea because here a manual step is required. And who knows, when I go to sleep in the night, my website becomes so famous so that people overnight use the thing and the server crashes. So yeah, so manual is not a good idea. So yeah, manual is not a good idea. We should go for some auto scaling. So before going to auto scaling, so we have just talked about, so this is our own machine, which may be my laptop. This is the cloud machine, right? And now how the Docker or the containers can be deployed in cloud. This is the third step which we will talk about. Because I told why we'll use Docker, because Docker is very easy to maintain the dependencies of the project. It is a lightweight thing instead of using the VM. So that's why we are talking how the containers and the cloud can be used together. So the same thing, we have machines, we have our model or the code, we have the user, we have the load balancer. So this model can be packaged using the Docker, and it can be deployed on all the machine using the Kubernetes. So as I told, that Kubernetes is the thing which can help us in auto scaling over here. So that's how we can use it. So whatever the existing architecture was there, on top of that, we just need to include the 2 tools and we are all set to go for the production, at least in cloud. But यहाँ पे we have to manage our own server, and also we have to pay for, we have taken a rent on machine on rent. We have to pay for every type. Even if the user is not using the machine, we have to pay for it. So that's one of the major drawback over here. So we'll see how this drawback can be overcome. Because in production, if we are not, some user is not using our machine, it's better not to pay for it, because the cloud person will charge for 24 hours. And if it is only used for 8 hours or 6 hours, then why to pay for 16 or 18 more, 12 more hours? So it's better to just have some architecture in production such that we shouldn't pay much. So that's why here comes a next thing called serverless. We don't need any server. Without server, we can deploy, and any number of users can use it. When I heard this for the first time, how is this even possible? Because server, too, I can feel I have set up the server, a lot of servers, but it was literally a very amazing thing, but a good idea. And deployment over the serverless is very easy. Just make a zip file and just keep it on the cloud. Things will work. So there are some extra tooling is required, but yeah, those headaches are also taken by the cloud person. So it's a very good way to deploy, and a very good way to save the money in production. So it's like a cloud is there, person is there. So there is something called Lambda function. So this I'm talking with respect to AWS cloud, Amazon Web Services cloud. We have a lot of cloud like Azure cloud by Microsoft. We have a cloud by Google called Google Cloud. So they have a different variants of the same functionality, Lambda function. So let's say we are in the AWS domain, there is a Lambda function. So what exactly we do is, like, we have a code, we make a zip file of the code along with some extra things are required. We just deploy it to this Lambda function of the AWS, and rest everything is taken care by this Lambda function. So there is no server. When I say no server, so in the web application, we have Nginx, we have something called Unicorn. So those things are not required. So all those things are not required, and this Lambda will take care of when the request will come, it will just scale to the machines automatically. So load balancing is happening here. So this is a good architecture to go in the real world scenario, and this is very much maintainable also. And a lot of people are using this. It saves a lot of money. So it's like when a person will request, then only it will try to use the computers of the cloud. Otherwise, it won't. And it can scale to any numbers of users without servers. So yeah, hardware has to be there, but server, I'm talking about software part, that is not required. So your servers can't go down if you don't have any. So just okay. Now there is one more advantage of this, like debugging and some canary. Talk what it is. I am making some change in our code before I am deploying it to the large number of user. I may want to do a beta testing of it with a limited number of user. So that is also allowed by the Lambda function. So for the if we are using the Docker directly, so there we have to separate a separate instance. But in Lambda function, we have a build. We have an inbuilt functionality called canarying, which allow that we can host the same zip file of in two different versions, and yeah, a user can access any one of them depending upon the how we make the request. So that's one of the great advantage of this. Also, rollback is easier. Suppose I have made some changes, deployed on Lambda for testing, for beta testing. So there, if it is not working good, some problem is there, then what we can do is like we can revert those changes immediately without affecting a majority of the users, because we have two different versions on the Lambda. So yeah, that's one thing. So yeah, so this is all about how we can deploy the models. But as I told, there are some deep learning models which make extensive use of GPUs. So there, if we want to make extensive use of GPUs, these are not a good options right now, because the GPU computation is not what is provided by them. Although in future, I think they may integrate, or they may have integrated. So yeah, so if we so model serving is basically talked when we need to use the GPU. So that's an important requirement here. So a TensorFlow is a library which has an inbuilt module which does this serving. So this is why Google. Then Amazon also have a separate library that's called MXNet. It has also a model server. Then University of Berkeley also has a Clipper. This is a very difficult thing. I don't know. They have developed, but very few people use this. Then there are some more startups working. Like one of the tools is like Algorithmia, which make deployment of ML model very easy. So yeah, a lot of things are happening. And even not only GPU, just for the information, we have TPUs and some other specific architecture is being developed for the deep learning models. So just like after CPU, GPU came, after GPU, TPU, and I don't know, there are some more things have come. I don't remember the name, but TPU till I remember. So yeah, a lot of separate architecture is coming for deep learning. TPU meaning tensor processing unit, GPU meaning graphics processing unit, or the graphical processing unit. Okay. So TensorFlow serving at a very high level is like it is trying to increase the throughput for the GPU, and Google use it very extensively, and it makes it easy to deploy a new algorithm and experiment, because as I told, in production, the easier the steps to deploy the things, the better it is to find out the bugs. And so recently the Google entire service went down. If they have not proper monitoring system or the things in place, it may have taken weeks or a day to find out what's the issue. So a proper deployment and a monitoring system is very much important over here. So yeah. Just like TensorFlow serving, MXNet is also a library for deep learning or the machine learning by Amazon. So they also have a model serving module. So it's like it uses Nginx and they define some model serving unit. So this is just an architecture, just like we have a client load balancer. So this is the serving unit and this is the model over here, just like we saw on the cloud. So it's like a cloud deployed on AWS, you can consider. So yeah, also they provide this model server as a part of SageMaker. So AWS has a lot, Amazon Web Services has a lot of component. So there we should try exploring this. So Clipper is also by Berkeley. So it is based upon the REST API concept, inbuilt REST API concept, and Docker. It uses the Docker because in the previous architecture, we don't have the Docker inbuilt. And we know Docker provide a lot of ways to manage the stuff, and it's a very lightweight. So yeah, this is also a good tool, but yeah, even I have not used, so I can't comment much about this, but this is just for sake of complaining that this is one tool. If we want, we can use this things. So yeah, containers, Dockers are very good way to go about. So Algorithmia is also one of the tool developed by some startups. So here it's like when you do git push, it will just try to make a AI layer. So AI layer, it feels a very high level term, but it's like when you do git push, it will deploy the thing. So yeah, they have automated it to such a stuff. So yeah, just to name that, there are some startups just building to on the deployment of AI models, because this is a very great way to reduce the time and manage the things. So people are paying for this very much, and yeah, good way. There are much more improvement needed, and all those things can be done. So also there is a Sheldon. So it is based upon the Kubernetes. As I told, someone worked on the Docker part. So someone trying to use the Docker net and Kubernetes integrate both. And yeah, Sheldon is the name of that module, we can say. And yeah, internals, I don't know, but yeah, this is at a very high level how this is. So just to summarize, if you are doing a CPU inference, just go serverless using Lambda. And the dream is deploying Docker, because Lambda, I told, we are using a zip file in Docker. We have to write a complex file. It's not a complex. If we have a written 1 or 2 file, we'll get a good idea. So yeah, some people may be working on that domain probably. So next thing is like Lambda or Docker, depending upon your model needs, which we can do. And GPU inference, if we need, we can use the servings, the TensorFlow serving or the MXNet serving or the Clipper. Yeah. The screen is freezing. Okay. Yeah. So we have talked about this CI part. We have talked about some deployment part. Well, now let's see some monitoring. So monitoring means we'll just try to monitor the model. So the cloud has each cloud has a lot of monitoring tool, but one of the standalone tool is like Kingdom Server Monitor, which okay. So yeah. So it's like detecting what's happening in the model, if something goes wrong or if some skew data comes, how to refine the model. So all those things are happening. So you can consider this is a very important part if we are going into the production, and it's a must, because otherwise sometimes the things may go wrong if we are not monitoring, and the system won't improve if we have some different data coming, and if we are not trying to fine tune our model on based upon how the real world data is varying. So yeah, this is also one important aspect. Yeah, so now we'll talk about some hardware deployment like Android, iOS, and what are the things, libraries available, how we can do it, and all those things. So yeah, embedded and the mobile frameworks are less features. It has less power. So the PyTorch and the TensorFlow library have a lot more component, but the mobile frameworks like TensorFlow Lite, we have PyTorch Mobile, we have, it doesn't provide so much support because it's a lightweight made for mobile and everything. So we have to be careful with what architecture we are using, but there is a turnaround for this, how we can come with a better thing. Then some interchange format we'll also look at, and then how we'll see the large model, because if you remember, I have talked about some examples yesterday using the GPT-3. So that's a very large model. It has a billions of parameters. So it can't be run on our mobile or anything. So how we can distill the knowledge, how we can reduce the network sizes. These are some problems which already worked upon. So we can use the libraries and try to use deploy if we have something, or even we'll try to work on the improving some other. So there is always scope for improvement in terms of how we work the thing and how you can use the thing. So yeah, one of the thing is like TensorFlow Lite. So as I told, TensorFlow is a library for developing the machine learning or the deep learning model, and TensorFlow Lite is a lightweight version of TensorFlow, which allows you to run your models, machine learning or deep learning or NLP on the mobile phone, whether it's iOS, whether it's Android. So right now, these two are the. Okay, someone is messaging something. No, sorry. Okay, so TensorFlow Lite is a set of tools to run the TensorFlow models on the mobile devices like Android, iOS, embedded devices. It may be Raspberry Pi or anything. Some IoT devices also, some processors and all. So it enables us to on-device machine learning with low latency and a small binary size. So that's the overall idea. So just at a very high level, what it does is like pick a model, just like we use the SVM models, but in production, no one uses the SVM nowadays. So they must be using some deep learning model. Let's say the some model called GPT. Let's assume it's a very large model. So we need to convert it to some format so that this TensorFlow Lite should understand it. So first thing is the conversion, then we'll deploy on the mobile. And also before deploying, we'll try to optimize, because see, 32-bit floats working on the mobile can take some, because float computation is a time consuming than the integer computation. So that's why some of the optimization is like, instead of float, work on the integers. So even I have this question of how this 32 can be managed by 8-bit. I haven't gone into those detail, but yeah, so those things can be looked upon if we have some more time. And yeah, so this is how the TensorFlow Lite at a very high level works. So it try to convert the bigger model into some smaller model. So these are some important, we say usually that this TensorFlow Lite allow machine learning at the edge. At the edge meaning we do all the computation on the mobile. We don't go back to the server. We don't send the data to the server and then come back. So I think most of us have a mobile phone. When we click some photo, you may see the machine learning model or the deep learning model try to optimize our photo. So that's happening on the device. It's not like it's going over the photo is sent to the some server of Google. Let's say I'm using Google Pixel. So it doesn't go to Google server and come back. It's happening on device. So that's one of the, so you can consider this is what you use. TensorFlow Lite in action is happening over there. So some of the requirements for this at edge computation is like latency. There is no round trip to a server. That's the first thing. Privacy, because some data we don't want to send to the server, because data privacy is important. Some user care about. So yeah, privacy is, and also privacy is major concern in ML domain. A lot of people are talking about how we can do a ML with privacy. So yeah, a lot of things are going in this domain also. Then connectivity is not required, because as I told, computation is happening on our phone only. So power consumption also is not required much, because network is not required, because if we have our internet users, then power drains very easily. So yeah, so these are the things we should consider, and this all things are taken care by the TensorFlow Lite. So yeah, in our generation, we have a libraries, we can use it if we just have an idea and we can build something. But if you just consider maybe 4 or 5 years back, this was not there. So I don't know how people used to do that. Maybe they have inbuilt or in-house things, and yeah. Okay, so few of the TensorFlow Lite users, we use Google Photos, we use keyboard suggestion, we use Gmail, we use Google Assistant. I don't know what these symbols means. Nest is we use, and yeah, a lot more are there. If you go on their TensorFlow Lite website, they'll talk about a lot. So I'll just give a basic idea of this. Just I'll go on the site. So yeah, so there is a BERT question answering. So this BERT is a model. So it is one of the good model. It is one of the best model, I would rather say. So it is based on this. So there is a transformer model which came in 2017. Based upon that, in 2018, Google developed a model called BERT. So it can be used for any purpose. So just to give you an idea. So what is, so see, these models are already provided as some, this is a BERT model, and let's say this is already running on some cloud. So I am saying, what's my name? I am saying the context, my name is Clara and live in Berkeley. If I do compute, see, it told Clara. It is fast enough because it's a robot model, but proper BERT model is a slow enough. So because it has a almost 340 million parameters, unknown parameters, which we have to learn. So almost GBs, the size of this model is in GBs. So yeah, so that's a very use if we want to work on our mobile devices. So to overcome that, so that BERT can be used for a lot of things. One of the things is question answering. Like as I told, question answering example I gave. So what they did is like they used the TensorFlow. So this TensorFlow is also a library by Google. So what they exactly did is like they use the TensorFlow Lite and convert this BERT model into a BERT Lite model, and you can see mobile BERT is 100 MB. GBs has got reduced to MBs, and see the performance has come to milliseconds. So earlier it was used to take almost in seconds. Now it has come to take millisecond. Now we may wonder how they are doing this, but yeah, there are a lot of techniques going behind the scene. So they have also shown the example, like I am passing some passes. Who is the CEO of is the question Sundar Pichai, which is a very fast way to work. So if we know, so yesterday I was talking about at a very high level models, but if you have to deploy, you have to use the TensorFlow Lite. So this is the TensorFlow Lite. If you go to, they have also provided a sample code. So these things you can just use as a as a very high level. So they have also provided all the code for Android and iOS. So how it can be used and everything. See, they are providing everything, that QI client is there, whatever. So I won't go into the details of all those things, but yeah, the basic idea is like TensorFlow Lite convert a heavier model into the lightweight model, and we can deploy on the web, we can deploy on the iOS, we can deploy on the Android. So yeah, that's a overall idea. Okay. Yeah, so as I told, there are two famous deep learning libraries in today's world. One is the TensorFlow by Google, and the second is the PyTorch by Facebook. TensorFlow is a little bit difficult to use in a sense that it has some, so both uses the concept of some graph, but it is difficult to use the TensorFlow. PyTorch is more user friendly, and a lot of people are using PyTorch nowadays. So we'll also talk about how we can combine the PyTorch and the TensorFlow models. So PyTorch model is like, we have some model in PyTorch, let's say BERT. BERT can be written in PyTorch, BERT can be written in TensorFlow. So we can try to convert into some, so these are some optimization steps like quantize model. So here floating point to integer conversion we can do. We can write some script to trace down the model. Some model optimization can be done. So, and then deployed on the Android or the iOS, whatever it is. So PyTorch also has so there is a PyTorch and PyTorch mobile, just like we have a TensorFlow and a TensorFlow Lite. Yeah. Yeah. Okay. So also based upon this for, and so you see, if we are an Android developer, we want to just use the concept in our app instead of just building the ML model. So that is also one of the option, because some people don't want to go into the math part of the ML. They just want to see what Android provides or the what iOS provides. So yeah, there is a core ML. It's a library released by Apple in 2017. So yeah, if you want to build any iOS app, you'll get out all the functionality related to image, text, or anything as a part of API in this core ML library. So yeah, like NLP, Vision, some game playing kit is there, and you can build an app very easily. So see, because of these library, how the life is becoming easier. And also maybe at the same time, Google was also working on the ML kit. So this is also on top of the Android system, and it's these API you can use directly instead of training the model. And yeah, you can just get a out-of-box functionality. So just imagine how they are providing this functionality. They have pre-trained some model, keeping it on the cloud, using some TensorFlow Lite or something. They are providing some API, some model serving whatever I have told. So yeah, those are the things happening under the hood. So yeah, just think how many users are using this. If they don't maintain a good deployment system, their system will just get down in a day. So yeah, those things are important. Yeah, some people are also trying to develop more libraries based upon all those things. So yeah, even React is one library which is very good, and it's a web library, but based upon on top of it, a lot of ML things are coming. So I know there is a virtual reality library on the top of React is coming. So yeah, a lot of things is happening in that domain also. So we considered how to handle the architecture now, because I told architecture was bigger, but this framework like mobile and all those things can't handle those things. So that is handled in how that was handled using the TensorFlow Lite or the PyTorch mobile. And it's a very good way, very practical way People literally use that in real world scenarios. Okay. Now let's say I am good at PyTorch, you are good at TensorFlow. I develop one part of model in PyTorch, you develop part of model in TensorFlow. How to combine the output of the models or something, how to interchange the format. So there is a concept called ONNX. This is called Open Neural Network Extension. Just like we have a JSON, like if we have a Java application, we have a Python application. If we want to exchange the data, we'll use the JSON data using some REST API something. So in the same way, if we have something called PyTorch models, machine learning models, and some models like TensorFlow, if we want to extend some data or the output or some parameters, so that can be done using ONNX. So that is also one great standard to interoperate, because PyTorch, as I told, is used by almost more than 50% of the people, or more than 70% of the papers coming use the PyTorch. Why they are using the PyTorch? Why they are using the PyTorch is like, it's a very user-friendly framework, easier than TensorFlow. And there are some frameworks like Cafe, which is good at inferencing. So yeah, so that's why we need something called open network, neural network exchange to communicate between two different model frameworks. So yeah, there are a lot more, but I just suggest use PyTorch as a beginner if you want to develop some model on your own. And yeah, TensorFlow is good, but it's more for some person who is like, because there is a lot, debugging in TensorFlow is a big pain. That's why we prefer the PyTorch. Yeah. Yeah. So this ONNX model is like, it provides the interoperability support, and it can works for all things like any device, Windows device, Azure cloud, or anything. So this is just a representative diagram. Okay. Now, so we have covered two things. Have to be architecture. If it is big, how to make it smaller. Second thing is like interchange format, like PyTorch and TensorFlow communication. Now, the third thing is like our devices have a little memory. It is slow, expensive compute. So all those things are there. So how to reduce the network size, quantize weight, or the distill knowledge. So yeah, so that's the next thing. So knowledge distillation is one concept which is a very good. It's like a teacher-student concept. So first train a large network, that's called a teacher network, on the data directly. Let's say Wikipedia data, it's a huge data, I'll train some network. Now I'll try to train a smaller network, and I'll train it in such a way that it will try to match the teacher network distribution. So here distribution, when I say, there is some probability going on, some math going on behind. So the idea at a very high level is like, we have some larger model which will train on a large amount of data. But from that data, I'll try to see, teacher has a large amount of knowledge. He or she can know a lot of subjects. But as a student, we give some small amount of data because we don't want to overwhelm a student, maybe first year student, with lot amount of data. So it's a concept like that. Knowledge distill out the knowledge and give to some student. So that's why I'm saying, first, I'll build a network which behaves like a teacher. Then I'll build a network which will behave like a student, and that student has a little knowledge. So network is smaller. So we can run those network on something called our mobile devices. So that's one way people have thought about this. And this is a very recent concept in this deep learning world. So I talked about BERT. And I also talked about in the previous slide, just gave example. I haven't gone into a detail of the BERT, but I talked about BERT, how we can use TensorFlow Lite to convert BERT into a smaller BERT mini. Now there is another concept based on this knowledge distillation, how we can reduce the model size. That is called, and that new model is called distill BERT. So I have already explained the concept, what it is. And that same concept is used in BERT, meaning I train a bigger BERT model, and using that I train a smaller BERT model. So yeah, so you can see overall our distill has about total number of parameter got reduced. It retains 95% of the performance. So performance hit is there 5%, but the model size is very low and the number of parameter is very low. So that's why we should try for using distill BERT. So just also to give an example of the distill BERT, you can see the same model. Hugging Face, we have a Distilbert Squad. So Squad is a data set, question answering data set by Stanford, and this model is trained on that data set. So if I just do compute, it will give me the Clara as a output. So yeah. So this is Distilbert. This is BERT also. I have shown the output. And then I have also shown the output of the TensorFlow Lite, how an Android, I haven't gone into the code, but shown how the TensorFlow Lite can be used for the purpose. Okay, so yeah. Okay, so we'll first go through few of the demos and let's try to. Okay, if you remember yesterday, we did a few examples of sentiment analysis. So today we'll see some movie review. It is like same only, plus minus review only. But we'll use the TensorFlow for this. Yesterday we used some spacey SVM. So we'll use the TensorFlow, and also the next thing which we'll use how the TensorFlow Lite can exactly be used. And there is a code available on GitHub by Google only, TensorFlow site only. So there we'll try to see how they are trying to optimize. So if you don't know this, Google Colab is a website by Google which allows us to use TPU, GPU free of cost. So if you see, I am right now connecting to the, so right now I'm on local system, I'm connecting to the cloud of Google. So it's totally free of cost. So see, it will allocate some CPU and RAM. So it's a very great way to just learn without setting up the things in the local system. See, it's connected now. See, the RAM is allocated disk, and you can also see they allocate a large amount of things. So yeah, so exact amount, yeah. You can see 12 GB RAM they have given, 68 GB disk they have given. Now also they provide some GPUs. If you see, I can see right now they provide GPU and TPU, both the things. So we don't need GPU in our local system also. Let's say I want to use GPU if we have some GPU for the model, and I'll just say that use the GPU. So yeah, so this is what at a very high level this is. So I am connected to some cloud that's totally free of cost, no configuration required. All the code will be saved to our Google Drive only. So yeah, you can install all the software whichever is required. So yeah, it's a very good way. And yeah, so I'll just install some software. If you see, I'm just installing pip install TensorFlow, and there is also TensorFlow some other library installing. So see, it is installing the library, done. Installation is done. So even for installing the library, our internet connection is not being used. That cloud has some internet connection that is being used. Okay, now see, now these are some importing library like TensorFlow. Say I am importing some libraries. Just for the information, I will be using some so okay, I'll just, it's a very TensorFlow hub. So TensorFlow hub is just like a GitHub, just like a Docker hub. So it has some pre-trained model, meaning maybe Google or maybe some XYZ universities, IIT Bombay have trained some model and then uploaded on the TensorFlow hub. So we as a person can directly use these models. Just we have to just install the library, and then just 1 and 2 line, it will just download everything. So it is very easy way to use the models without training and everything. So yeah, so as I told, BERT is there. A lot of things are there, a lot of things. So style transfer is also one good way. So here the GAN, I don't know. Yeah, I was not talking GAN. Yeah, okay. Anyways, so yeah, a lot of things are here. You can go and explore in detail if you wish. Okay. Where was I? Yeah. So here I am just saying I'll just use a pre-trained model, and that model is somewhere saved in the TensorFlow hub. It's like a machine, you can say, somewhere with the TensorFlow repository. And yeah, so I'm just importing the library. See, when we run the code and see, we get a more confidence that the things are working. See, it is saying the version of the TensorFlow is 2.4. So there is, just ignore this eager mode or whatever it is. And there is a TensorFlow hub where I told where the models are stored. Some version is there and GPU is available. Since I allocated the GPU, if I have used the TPU, then TPU must be available. Okay. Now, so yeah, one more thing is like TensorFlow is a very full-fledged system. Right now, earlier when I showed the yesterday example, I have downloaded a data set from the Kaggle and then on the local system and then ran everything on the local system. But this TensorFlow also has a module called TensorFlow TFDS, which has a lot of data set. If you see TFDS, there are some commonly used data set. So you can see a lot of data set is available as a part of this. So functionality also is available, and if you want resources, yeah, model and data sets. So TensorFlow how I already told, this is where pre-built things are. Even TensorFlow JS, we have something if we want to run in browser or using some node. See, we have a lot of data set, like TensorFlow official has some data set. You can see a lot of TensorFlow data sets on GitHubs. Yeah, there are papers they must have mentioned. Maybe I'm not. Yeah, see TensorFlow data sets. So see, they have data set related to question answering, object detection, image classification, image, audio, core, a lot of data set. So these data set are inbuilt. We don't have to download anything. That's what my point is. So that's why this framework is so good to use also. In PyTorch also we have inbuilt data sets. Inbuilt when I say they have downloaded a data set and kept on their server, as simple as that. Yeah. So let's say we download the data set. Because we have to download on the this Google server data set from TensorFlow, wherever they have hosted. So yeah, it hardly take 1 minute. It will be done very fast. So now it will download the data set, and also does earlier, if you remember, yesterday I used the scikit-learn test and split. By default, when you see do load and provide the split as a parameter, how you want to split, it will split the data set also. So yeah, see how easy it is to use. So that's why first we should learn the basics of how from the raw, and then once you look at more advanced framework like TensorFlow and PyTorch, these are very easy to use. And you will also understand what's going on behind the scene. What could be the possible code if I have to write. So these are the IMDb reviews data set, and it's downloaded to the root folder of the cloud. Yeah. So I'll just try to show you what the data sets are. So see, these are the data set. This was an absolute terrible movie. Don't Lured by the Christopher Walken or somewhere. So these are the 10 lines, first 10 lines of the data set. Now, these are some labels like plus 0 means negative label and plus means sentiment or label, whatever you want to say. So 0 means negative sentiment, 1 means positive sentiment. So yeah, that's what I have showed. Now let's talk about building the model. So I told first in any part, any machine learning thing, I talk about data, then I'll talk about the model. So just ignore all those things, text over here. I'll just tell you. Earlier, if you remember yesterday, we used the count vectorizer to convert that text into the some vector. Here we have some inbuilt models. So this is a neural network model in the TensorFlow hub. So we'll use that to convert that text into some vectors. So these are, if we know the internals, it's exciting, but at least at a very high level, I want to say this is a neural network model. If you pass the input into this, it will convert into some vectors. As you can see down also, you can see some vectors and all. So this particular line takes some text and convert into some vectors. Earlier we used one-hot encoding. So it's a good model. There are some other models also. So yeah. Now this is the model building part. So model building part we are adding some layers. So dense layer simply means neuron. So input will come, it will give some output, as simple as that. So here we are giving 2. So why we are giving 2, 3, we can keep more dense layer also. So all those things are hyperparameter we can try, but here we are trying to make a very small network, meaning a hidden layer with 16 neurons and an output layer with 1 neuron. So this is a this is a neural network. Earlier we used yesterday we used a support vector machine. Now we are using some neural network with one hidden layer having 16 neurons and an output layer having 1 neuron. So yeah, I think I'm using the term very vaguely. I should have drawn the, so okay, I'll just show you the, I was, let's say the image what I mean. Okay, it's just this network which I'm trying to build. So this is like a hidden layer. This is the text we are giving as a, this is the text we are giving as an input. This is the hidden layer in which this round is a unit, 16 unit, and this is the output layer 1 unit. So this we are visualizing like this, but in case of code, if we have to write, we have to write on top of we are building a model called sequential, meaning on top one after other we'll try to add something. Like first of all we added hub layer. Hub layer is nothing but text to vector conversion. Then we are adding a 16 layer thing, and then we are adding a one output layer because we want 0 and 1 classification. And you can see I can see the model summary also. So there is one layer called this input output layer. See how many parameters it has. If we could have learned from the scratch this model now, it would have taken almost a day or two to train this model. So they have trained this model probably on Wikipedia or some other data. So there is some dense layer. It has some 816 parameter. Then there is an output dense layer in which only one neuron is there, which has 17 parameters. So see, total number of parameters of our model is so much. If the data is even more, we can add this dense layer more. So these are hyperparameter. How and all those things is not the scope of this thing. But yeah, just to give a very basic idea. So we have data done, model done. Now we need some, okay, sorry. So as I told, we have something called every model is a maths. There's a lot of maths going on behind this thing. So we need some optimizer. As I told, the third step yesterday was, first is data, second is model, third is optimization. So in optimization, we need some function to optimize now. So that function is called loss function, and optimizer will try to optimize that. So yeah, instead of going into the detail, one of the inbuilt optimizer of this is Adam. The TensorFlow has some inbuilt, so there is some gradient, some calculus going on behind, which will be done. I am saying some loss as a cross entropy. So this you can consider how much the actual and the predicted things are varying. So that is loss. And metrics I talked about yesterday also, that on what parameters we are judging this thing. So that's all about this. So when I do model.compile, it will just attach the things. Matlab, model ke saath, it will try to find all the derivatives and all. Okay. Now I'll train the model. So this step exactly is the training. Now model creation is done. Now I'll train the model. So training the model, I am training for 10 epoch. I can train for any number of epochs. So when I say 10 epoch, meaning for the same data set, I am running through the network 10 times. That's as simple as that. And forget about shuffle. I do the data shuffling so that it doesn't learn the same thing. And I do verbose one so that it shows what's happening. So you can see the accuracy keeps on increasing. First time I fed the data, accuracy was 50%, then 67, 80, it came to 99. So see, the accuracy of this model has came to 99% with a neural network. Earlier, yesterday, when we saw some models, SVM accuracy was 92%. With just a simple neural network, the accuracy is 99%. Now we'll try to evaluate the model on some test data set. So on test data set, it performed 85% because the test data set may have a different distribution. We can improve this accuracy if we want, but right now the target is not to work on the accuracy part. The target here was to see how the model is working. And yeah, so overall in this example also, I have first focus on data, then model, then I have model optimization. That's it. So these are the three ways in which we can in which we can develop some ML model. Now, this is a development level thing. It's okay. But if we have to take this to production, how exactly we can do that? Now I'll talk about that with a simple example. Okay. So the same example, whatever I have talked about there. So this TensorFlow also give a version of Android and iOS with some TensorFlow Lite library as I talked in the slide. So let's go for Android part. So here, if you see what they are saying, whatever model you have learned, I'll try to simplify the model for Android. That's simple as that. There are few things which we need to install if you want to APK file and install on our system. So I don't have those installed right now, but I'll just walk you through some code. So yeah, see, they are saying we'll use some TensorFlow Lite interpreter to convert that bigger model. See how big the model was. Some lakhs mein parameter the, so much. So if you see the parameters, how much parameters we have, the number of parameters is like almost, see how large the parameters are, very large. So we'll use, there are two ways in which we can convert this bigger model for Android. One thing is called libtask API. So this is the API by default provided by Google as part of Android. So this is the API. TensorFlow task library. And then the other thing is like I can use the TensorFlow Lite interpreter directly. So both the implementations they have provided will just go through, since I think easier was like this. Yeah, this is a very easier way. I'll just show you the. See, so they have provided as an NL classifier. So whatever classifier here it is now, whatever I have seen the classifier here, they have provided that as an API called or package called NL classifier, right? And now our simple task is to like use this particular package and just call the functionality. So you can see from NL classifier, I'm trying to load the model. And if you see the model path, I'm saying text classification is the model which I want to load. If I want to load computer vision model, I'll write here computer vision. And yeah, that's how we'll load. And if we want to really classify, what I'll do, classifier.classify. As simple. See how concise this is. So all that done, all the that labor task is already done by Google. Okay, they have given us a very a package called NL classifier, using which I can load a very light TF light version of this model, which I have explained you over here. And just with 2 and 3 line of code, I am just loading the model and then I'm classifying the model. So depending upon what exactly classification is, we can try to do some more tasks over here. So here it's like find some best result and all those things. So yeah, see how easy or how efficient it is used for Android. Also, let's go look at some other tasks. So this was like API provided by Google, which is very good. Now another thing which we can do is like if the API, for some model API is not provided, so we can use TensorFlow Lite. In this case, we can use both because both options are there. So here you can see there is no API provided. I have to, there is something called TensorFlow Lite model is there, right? Okay, have I opened the same file? No. You can see, first see how many lines of code. Earlier it was very small code. Now see the number of lines of code has increased. And let me point out the main part where the things are happening. See, we have to do some padding also. Now I won't talk about padding, but yeah, something needs to be done if we are managing manually. So these tasks are done by Google beforehand. Okay, buffer load. Yeah, so exactly this load is where the exact model is getting loaded, and this is calling a load model. So this is where the exact load model is getting loaded. So load model file is an inbuilt function, and there I pass the model path, and you see in the model path I have given this thing because this is already on the TensorFlow hub, and then we'll try to convert. If you see, there is some metadata extractor and all those things. So these things even I don't understand because I don't work in the Android domain, but just to give you an idea that how these things can be used at a very high level if we want to use this. And then they are doing some classification here also. So yeah, but a lot of processing will be required here if we are trying to use the TF Lite converter by ourselves. So yeah, that's one thing. So yeah, this I have already shown. So yeah, if we have any questions or anything we can take, at least this part is done. Yeah, so if we have any questions, we can take.
Yes, participants, if you have any question, you can post it into a chat box.
Hello.
Yes.
Sir, I want to ask you that after converting the model into TF Lite, our deep learning model,
Yes.
and while deploying it into mobile, I just want to, what I can say, I want to just confirm or say want some something that if we deploy that model into mobile, how much size it will be, or what is the good size for that? Means up to 50 MB or up to 30 MB it is good, like that. Can you say on that?
So exactly, see, the exact size, let's assume that I am not using some machine learning model, then the size of the APK would be like, let's assume 40 MB. But now let's assume I'm using some ML model. So first we have to see which ML model I'm exactly using. Let's say in this case, I was using the text classifier model. I can also use the BERT model, BERT Lite model. I can use so many model, computer vision model. So these are optimized using the TensorFlow Lite. So exact size, I won't be able to tell you how much it is, but it will be the best which you'll get because TensorFlow Lite takes care of all those things very
Sir, I don't want exact size. Means if you have worked on this, you have worked on this, all these things, no? So I want just like whatever the model I have deployed on my mobile, and I have created that APK. So it is near about one is without quantization, it is near about 33 MB, and with quantization, it is 63 MB. So is it good, that size?
I think it's a good, but I am not see, I don't work much on the Android part. I mostly work on the research part of this problem. But if you are asking me the exact size variation, is it good or bad?
No, I am not asking exact. Means if you have worked on, so you might gone through all these things. So that's why I'm asking just suggestion or your view on this.
So ma'am, I don't work on the Android part of this, so I won't be able to comment exactly whether it is good. But I feel, if you ask me at a very general level, so I feel if we are getting 20 MB size or 30 MB increase, it should be good.
Okay. And when we convert that our deep learning model into TF Lite, after reduction, how much it will be reducing, up to what level it will reduce?
Okay. So,
means 10x or 12x like that, or up to 5x?
So if you see, I have told an example of BERT, this BERT question answering. So here you can see this mobile BERT, that is after reduction, it is of 100 MB size. But at a raw level, if you see, it's almost 750 MB. So almost 7.5 reduction happened over here. So it will depend upon the model to model.
Okay, so for a mobile net, you got 750 MB.
7.5 reduction is there.
Okay, 7.5. Okay.
Because I have worked on this model, there are a lot of models which I can't comment on depending on the model is.
Yeah, depending upon the model, it might change.
7.5 in BERT for sure, because I have worked on the BERT very extensively.
Okay, okay. For me, for mobile net, I am getting 12x speed up, 12x reduction in model size.
Okay. So I haven't used that XNet yet, but I know at a very high level about it.
Oh.
12x has been very good.
Yeah, yeah.
Hello.
Okay, thanks.
Thank you.
Hello. Hello.
Yes, ma'am.
This BERT model is used for the NLP, right? So is there any other application where we can use the BERT model other than NLP?
Ma'am, actually, BERT model is specifically pre-trained on the Wikipedia data and book corpus data. So BERT can only be used for natural language processing tasks like question answering, named entity recognition, classification, and so on. There are a lot of tasks you can use. But if you want to use some computer vision models, so there also we have some pre-trained models like I don't work in that domain, but there are some pre-trained model which I can give the pointers to. So like there we have LXNet, UXNet, and lot of network and also if you want to combine the image and text, so we have a model called video BERT and image BERT. So that works with a combination of image and text. So that's also possible. That's also pre-trained model. It came very recently.
Thank you.
Also, if you want to work with source code, like some code is there and some text is there. If you want to work on those lines, so you can also work. There are some models called CodeBERT and QBERT. So these are also some recent models which have come. These we say the multimodal data. So when I say multimodal data means like image is one mode, text is one mode, speech is another mode. So there are some pre-trained models in these domains you can use.
Okay. Thank you.
Any other questions? Participants? Okay, I have one question to ask. When we need to deal with the multiple hidden layers in between, so what kind of optimization approach we should add for optimizing the hidden layers to maximize the accuracy of the result?
Sorry.
If it is a classification problem.
And the voice is echoing. Can you repeat the question again? I don't know. It was not strong.
Okay, am I audible?
Yes, ma'am. It's good.
Yeah, shall I repeat the question?
Yes, ma'am.
Yeah, I was asking that if we are working on some classification problem and we have multiple hidden layer and we need to think about optimizing the number of hidden layers. So can you suggest any of the model or any of the methodology that will optimize the hidden layer to get the accuracy?
Okay, so first thing is like for any problem, any classification, let's assume you are talking in the classification domain. So first, we should proceed in an iterative way, meaning just put one hidden layer, put some neurons over there, and then try to see how the model is performing. Then try to add some extra layer, put some neurons there. So this is one of the manual process, but there is a systematic way which I'll just show. There is one second. So this is called grid searching. So these are the hyperparameters where we can as you told, how many hidden layers, or maybe in a hidden layer, how many neurons are required. So even number of hidden layers, number of neurons in a hidden layer is a hyperparameter, right? So how we find out the exact hyperparameter size? The first thing is like a grid search. You just try to how many hyperparameter do you have? Just try to find out a proper grid or the pattern and then try to do a grid search in this. The second thing is like you can do a random search. So these are the real scenarios where people do grid search or a random search, or they just try to be very broad. Then they come to find like they just found this is the best performing region, and then from there they just come to some smaller region. So that's how we can find out these things. So these are like experimental empirical result which we have to try with a different permutation, and there is a systematic way of doing this that's called hyperparameter tuning. So there is no automatic answer or the right answer for this. Maybe a 4 neurons can also give a good result, or 8 neurons can also give a good result. And there is a theory which says a neural network with 2 hidden layers can approximate any function which you want. It can work for any data, but we don't use that. The reason is like it's a very hard to train. Train in a sense, if it is a deep number of neurons are more, it's not good for training, and a lot more things are there. So theoretical bounds are there, which talks about these things.
Okay. Okay. Thank you. Any other questions, participants? If there are no questions, we shall conclude it. Is there any question? Okay, as there are no questions, I would like to thank Mr. Suraj Kumar for delivering wonderful hands-on session on on the NLP concepts and related neural network concepts. So it was a very interactive and informative hands-on session, and it will definitely help us for enhancing our skills. So thank you very much for the valuable insights through practical approach. And as we come to the closure of day 3 sessions, I would like to thank our chief patrons, Honorable Vice President and Chairman Shri Satish D. Patil sir, our beloved campus director, Colonel S.K. Joshi sir, our principal, Dr. Vijayam Vadai sir, Vice Principal, Dr. Mrs. C. Malati madam, HOD, Dr. Vinayak Kutava sir, and chief coordinators of this event, Mrs. Shanti Guru madam and Mrs. Neelam Patil madam. I also want to thank all my organizing team members for their continuous guidance and support, and also thank the participants for their patient listening and active learners. So thank you once again to all of you. Thank you, Mr. Suraj Kumar sir. It was a wonderful sections on both the days. Thank you, sir.
Thank you.
Here we will end today's session, and we will see you tomorrow at 10 a.m. So with this, I declare that the session is over. Thank you all. Stay safe and keep learning. Thank you once again.